So welcome to the second part of finite element analysis for SolidWorks. In this session, we'll see application of finite element analysis using SolidWorks. In this section, we will be looking for certain examples related with structural analysis problems only. Let us see how SolidWorks can be used to solve the problem shown on the screen. Here, the problem is analyze the given problem using finite element analysis software and determine the nodal displacement and support reactions. Display the deformation and stress distribution contour plots. Choose suitable material and tube for the member. We have a cantilever beam that is supported at one end and is free on the other end. It has two point loads acting at certain location. Now we have to see how this can be modeled in SolidWorks. In SolidWorks, as usual we come to the file, start a new modeling environment, choose the part and click OK. You get the working environment. Here we have to model that particular cantilever beam having length 1 meter with 1000 Newton and 2000 Newton loads on two locations. We have learned in the previous session that the loads, boundary condition computations are all happening at nodes. So when we want to apply a load on a particular point on the structure, we have to ensure that there is a node to apply the load and boundary conditions. So in this case, we have to provide boundary condition of fixer at one end to show that it's a cantilever beam, and there should be two nodes to show the 1000 Newton and the 2000 Newton. Let us see how we can model the situation. For that, we have to choose the working plane. I'm going to choose the front plane and I'm making it normal to me. Now I go for the line to model the beam. So I'm starting from the origin and I'm making a line like this, one segment here and another segment continuously to another location. Why I have drawn two lines instead of a single line? Because when I break the line, there will be a node automatically generated. We need this node as well as this node to apply the force. Now let us do the smart dimension. This is 500 millimeter and this is also 500 millimeter. Now one part of the model is over, so I'm going to exit my sketch. But this is just a line. In order to give the physical feel of the object, we have to choose a material and we have to show cross section for that beam. Let us consider a square tube cross section for making the beam. For that, we have to use another option called weldment. You can see that weldment here. So weldment is taken where you can see structural member. If you click on the structural member, you can have many options for cross-sectional tube. Says there are square tube, angle, C-channel, pipe, etc., etc. And we need to choose square tube. For this particular case, I am choosing square tube. And of that square tube, we have to choose what is the size of square we want in our construction. Let us choose 40 millimeter by 40 millimeter square with 4 millimeter thickness tube to withstand this. After choosing it, simply click on the line. Then you can see that there's a tube generated automatically. Click on the other one. And once you click all the members, click exit sketch or complete process. So if you closely look onto that, you can see that there's a cross section of tube generated like this. Now our duty is to analyze the situation. For that, we need to fix this end and we have to apply load over here as well as here. For that, we have to go for simulation. Simulation is available in this tab. You click on the simulation. Once you click on the simulation, you have to select a new study where you can choose what kind of analysis you are going to perform, whether it's a thermal problem, structural problem, fluid problem, etc. So our intention is to conduct a static structural problem. So I am going to choose static, then click OK. Now we have landed on another set of tabs over here that is suitable for conducting the structural problem. While we do the analysis, we have to go one by one through these tabs so that we can systematically complete the process. First, we will start with this. We will apply the material. We have selected a wire tube, but what is the material? You have n number of materials available over here. Okay. For the sake of analysis, say I am going to choose alloy steel. The moment you click over here, the information, data about the steel are available over here, like elastic modulus, Poisson's ratio, mass density, etc. Yield strength can also be seen here. Here we are going for the material property. We are choosing it as linear elastic isotropic material. Isotropic material means the material property is uniform across the material. If it is orthotropic, if you choose, the meaning is that the material has got orthotropic property, that is property variation across 90 degrees. Here we are going for a uniform material property, isotropic, so choose isotropic, and you have the option to select units also. We will go for the Newton per meter square, that is megapascal. You click on apply so that the material property is applied on our model. Now choose close. So the material, now what you see is a mild steel having the given property. Now how to complete the analysis? For that, we had to go for next one. It's a fixer. So click on the fixed geometry, and so that we can fix this particular node. So just click on the node so that the node will have all the degrees of freedom arrested. A node on the space will have 6 degrees of freedom, like you can move x, y, z, and you can rotate along x-axis, rotate along y-axis, and rotate along z-axis also. But for a cantilever beam, this node will not have any movement, so all 6 degrees of freedom are arrested. So we are arrested here. Now we are going to apply load over these nodes. For that, we have to go for external loads. Click over here. You click on force, what you have to apply. When you click on the force, it will ask where you have to apply the force. Here, in fact, we had to apply force on these joints. Okay, so click on the joint, and you have to click on the joint here. This is a joint. There, it will ask the direction of force. For that, you have to show a reference. With reference to which plane? For that, we will show one plane. Say I'll choose this surface, this plane. Okay, this plane. So the force will be acting parallel to this plane from top to bottom, this node. So you choose a plane, then perpendicular to the plane you apply the force, and the force you are going to apply is 1000 Newton. The moment you click over there, you will see the force acting on that. Okay, this node. So that is one force you have applied. So you can see that the force is applied here. Okay, you can see that. Similarly, you apply force on the other point also, like external advisor, apply force. So you are going to apply on node, which point, this joint. Okay, along which surface, this surface will show. Along parallel to that surface, you apply the force. So say 2000 Newton. So you can see that it's applied here. And if you want to show reverse direction, you can show like this also. Okay, you can reverse direction as well. So we have thus applied force, and what is the force there you are going to apply? 2000 Newton. Thus you have the modeling is completed. Now we have to discretize the domain. For that, you have to apply create mesh. You go for run this study. So it will apply and it will get the study value. What result you want? You want stress along this one requirement. Another one is what is the displacement of the road when you apply the load. For that, you right click on this and choose edit definition, and you choose what is the value you want. So if you want the bending stress or whatever the kind of stress you want, you just click there and then click OK. So it will give you the value. Similarly, if you want to see the displacement, click over here, right button, then edit definition. Being the force applied in vertical direction, Z direction, you need to get the displacement in Z direction. So this is the direction we are going to check. X and Y, we know that it won't have lateral dimension. So this is the one. Click OK. Now, if you want to see the displacement, what happens is you just double click over here so that you get the dimension value here. See, the maximum deflection is 3.32 into 10 raised to 1. That is 33.23 millimeter in this direction. Is it acceptable for you? May not be. 33 is a huge displacement for this. So that this won't withstand the load. So we need to redefine the cross section by using some other cross section. That's what we had to understand. Similarly, for stress distribution, if you click, see, yield stress is 6.2 into 10 raised to 8. And what is the maximum stress developed? It is 4.5 into 10 raised to 8. So this 4.5 is lower than the material property. In that case, material will not fail. Instead, it will bend through some distance. Whether that bending is acceptable or not, that is our decision. So this is how we do the analysis.